So in the previous classes, what we discussed about the config map and secrets. So config map and secrets are used to avoid the hard-coded properties in the application. Config map is used to store the data in the key value non-confidential data. Config map allows us to decouple application properties from Docker images so that our application can be deployed into the environment without making any changes for our Docker image. Right, guys? You already know this, right? The secret is also one of the Kubernetes resource. Secret is used to store confidential data in key value format. Secret is used to store the confidential data in encrypted format, guys. So you already understood, right? The dynamic properties, it will impact our application will ready environment specific properties. Config maps and secrets will provide in the every environment. So the config I already show you, right? The the example. So example of the config maps and secrets. First create the config map, create the secrets, deploy the MySQL DB container using the config map and secret data. Test DB is deployed or not. Deploy the application by using the config map and secret data for the DB properties. Test application deployment. For this purpose, I will show you. Yeah. So not created a config map. Yes. Okay. So I created a file, guys. I sent an email to the Amazon Web Services. I raised a case, guys. I want to reactivate my account. So once we reactivated, we'll show you guys. So where you guys are practicing daily? We're not practicing, huh? Very good. Yeah, guys. Example of the config we already shown, right? The we will create the two files and the application container and the database file, and we will apply this one, right? The stateless application versus stateful applications, guys. Stateless application versus stateful application. The browser and stateless application, stateful application, MySQL DB, guys. So what is a stateless application? What is a stateful application? So what is a full set? So what is a stateful and stateless applications? So what is a stateful set? So a stateful set is the Kubernetes controller used to run the stateful application as a container in the Kubernetes cluster. Yeah. A stateful stat is a Kubernetes controller used to run the stateful application. Used to run the stateful application as a container in the Kubernetes. Stateful application as a container. As a stateful application as a container in the Kubernetes cluster. Stateful states assign a sticky identity, an ordered number of starting from 0 to each pod instead of assigning random IDs for the each replica pod. You understood? So there is another identity is added. The identity will add the from 0 to, so 0 to each part, 0, 1, 2, 3, 4. So if you are not using stateful stats, it automatically create the random numbers. A new pod is created by cloning the previous pod's data. A new pod is created by cloning the previous pod data. If the previous pod data is in pending state, then the new pod will be not be created. So if you delete a pod, it will be delete the pod in reverse order, not in random order. So right, the stateful set, something a headless service. So pod 0, pod 1. So pod 1 having the persistent volume kinds and persistent volume climb, PVC, and the persist volumes and persistent volume climb and PVC. So these are the, so this volume is the node 0, this volume is the node 1, and this pod is created under the node 0, this pod is created under the node 1. So for the stateful set, we can use the, we can use for the, it will create the pods sequential order. So what is the difference between a deployment and a stateful set? So deployment will create the pods with random IDs. Deployment will scale down pods in the random order. Deployment pods are stateless pods. Deployment pods are stateless pods. So stateful set will create the pods with a sticky identity. Stateful set will scale down the pods in the reverse order. Stateful set pods are stateful. So for application deployment, we will use the deployment. For the database deployment, we use the stateful set, guys. So guys, understood? So for the application deployment, we use the stateless application. For the stateless is nothing but a deployment. So the manifest file, we can use the deployment. For the databases, we can use the stateful set. Stateful stat. Yeah, guys. What is a Helm? Guys, what is a Helm? So Kubernetes Helm, guys. What is a Helm? I'm searching for the images. Helm. What is a Helm, guys? What is a Helm? Yeah, Helm charts, guys. So by using the Helm chart, what is a Helm? Right. 1 second. Wait for the program to respond. Yeah, what is a Helm? Helm is a package manager for the Kubernetes application. So what is a M, guys? What is M and RPM? Guys, what is M and RPM? Guys, what is M and RPM?
M and RPM is used to uh, install the packages in Linux.
Yeah. So M is the package manager for installing the packages, installing the softwares on the Linux machines, right? So M is a package manager for installing the packages on CentOS 7 mission. The same way, I want to install a package on, so want to install a package on Kubernetes. So want to install a package on Kubernetes. So wants to install a package on Kubernetes. So Kubernetes cluster, how you can install the packages by using the Helm charts. So by using the Helm charts, we can install the packages on Kubernetes cluster. So create a cluster. So for example, I want to install the packages. Which package I want to install? I want to install the package. For example, monitoring tool. So what is the monitoring tool we are using, guys? So we are using the monitoring tools, guys. Tell me what are the monitoring tools we are using for the Kubernetes? So we are using the Grafana. So we are using the Grafana and Prometheus. So so what is that tools, guys? Prometheus and Grafana. Prometheus and Grafana are the monitoring tools. So I want to monitor the nodes. I want to monitor the pods. So how you can monitor? First, we need to install the Grafana, Prometheus is Grafana on our pod and on our node, right? So how you can install these packages? We need to install the package by using the Helm charts. So we need to install the packages by using the Helm charts. Helm charts. Guys, understood? So Helm charts and metrics also. For example, metrics. Uh, so metrics. So how you can measure the metrics? Some metrics in CPU memory. So how much percentage of a CPU, how much percentage of a memory is using this pod? So this pod is using how much memory? The RAM node is using how much memory? So for this memory, so we can set the threshold for the we can set the threshold for the CPU memory, and it will automatically launch the another pod or another instances. So that is nothing but a auto scaling. What is that, guys? So that is nothing but a auto scaling. Based on the metrics, we need to increase the instances, or we need to decrease the instances based on the metrics. So that is nothing but a auto scaling. Auto scaling is achieved auto scaling. So here auto scaling concept, and by using the Helm chart, so we can install the Prometheus and Grafana. And what is the log monitoring tool, guys? What is the log monitoring tool? So log monitoring tool is ELK. What is that, guys? Elasticsearch Logstash Kibana. So Logstash Kibana. And what are the components, guys? uh, Deployment guys. Deployment, replica set, daemon set, daemon set. So the replica set, it will use the replica as deployment. So what is the daemon set? I already told you, right, guys? Uh, whatever the whatever the pods are running in the node, worker node 1, the same pods will run on the worker node 2 also. The same pods will run on the worker node 2 also. So I want to, so here how many pods are running? For example, 4 pods are running, right? So in these pods I want to I want to install the ELK on these pods. How we can install, guys? We can install the, so I want to monitor these 4 pods. So you can monitor these 4 spots by using the ELK. So ELK logs. So ELK logs, so we can monitor this. We can monitor this, guys. Is understood? Little bit. Guys, understood or not? Yeah. So Helm is what is a Helm? Helm is a package manager for Kubernetes applications. Helm allows you to install or deploy applications on a Kubernetes cluster in a similar manner to Yum apt for the Linux distributions. Helm manages Kubernetes resources packages through the charts. So Helm manages Kubernetes resource packages through charts. A chart is a collection of files organized in a specific directory structure. The configuration information related to the chart is managed in the configuration. Finally, a running instance of a chart with a specific config is called as a release. So finally, a running instance of a chart with a specific config is called as a release. So Helm package manager. So Amazon Linux and Ubuntu Linux. So what is the use of which packages are using? Yum package manager, apt package manager, m install git, m install java, m install maven. So these are the package manager for the Amazon Linux and Ubuntu. So Helm architecture. What is the architecture of the Helm? So this is the chart repository. In the chart repository, you can create the Helm charts, and so you can apply the Helm charts to the KBA server. API a server. What is a Helm chart? Helm is a package manager for Kubernetes cluster. Helm is used to install a required software in Kubernetes cluster. Helm will maintain charts in the chart repository. So Helm is a package manager for Kubernetes cluster. Helm is a package manager for the Kubernetes cluster. Helm is used to install required softwares on the Kubernetes cluster. Helm will maintain a charts in the chart repository. Helm will maintain charts in the chart repository. Chart means collection of configuration files organized in the directory. Guys, now tell me everyone. Everyone can speak out. What is a Helm charts? What is a Helm? Guys, what is Helm?
It's a package manager for KX cluster.
Uh,
It's used to install required software in KX cluster.
hmm,
It will maintain charts in a chart repository.
Same like the chart repository. We have a in the M repository, right? The same like as a chart repository.
Okay.
Chart means collection of configuration files organized in a directory. Okay. So metric server. So what is a metric server? A metric server is nothing but a uh, to get the data on the Kubernetes cluster. So metric server get nodes metrics kubectl top get nodes metric node metrics. Node metric means the CPU and memory utilization for the nodes. Kubectl top nodes. Get metrics for the pods. Kubectl top pods. So by default, metric service is not available. By default, metric service is not available. Metrics server is an application. Metric server is an application that collect the metrics from the objects such as the pods or nodes according to the state of the CPU and RAM and keeps them in the time. RAM keeps them in the time. Guys, understood? So metric server is an application that collect the metrics from the objects such as a pod and nodes according to the state of the CPU and RAM. So metric server can be installed in the system as an add-on. So it will not, by default, it will not installed. So you can take and install it directly from the repository. Which repository? Chart repository. I want to install the metric server. I want to install the metric service. So metric server. So by default, it will not come. So metric server can be installed in the system as an add-on. You can take and install that directly from the repo. So, Kubernetes monitoring. What are the Kubernetes monitoring? So, we can monitor our K8 cluster and cluster components using the below software. So, can monitor our K8 cluster and cluster components using below software. So, what are the Kubernetes monitoring, guys? Everyone can speak out. What are the monitoring tools, guys? So, what are the monitoring tools? Prometheus and Grafana. So, Prometheus and Grafana.
Grafana.
Yeah, I want to install these two monitoring tools. So what is a Prometheus? Prometheus is an open source system monitoring and alerting toolkit. Prometheus is collect and stores the metrics as time series data. It will collect as a time series. For example, so every 1 hour or every 15 minutes or every 5 minutes or every 10 minutes. So for example, if we need to collect the data every 10 minutes or every 5 minutes. Prometheus is collect and store the metrics as a time series data. It provides out-of-the-box monitoring capabilities for the Kubernetes container orchestration platform. So Grafana is an analysis and monitoring tool. Grafana is a multi-platform open source analytics and interactive visualization web application. So so Prometheus is not, it will collect the information, but it will not showing as a graphical user. But Grafana is an analysis and monitoring tool. Grafana is a multi-platform open source analytics and interactive visualization web application. It provides a chart, so graphs, and alerts for the web when connected to the supported data sources. So Grafana allows you to query, visualize, alert, and what is that? Grafana allows you to query and visualize and alert on the understand your metrics no matter where they are stored. Create and explore and share data boards. Grafana will connect with the Prometheus for the data source. So Prometheus architecture, something like pull the metrics. So it will pull the metrics. These are the Kubernetes. In the Kubernetes, Prometheus is server. So alternative manager. So these are so it will push the alerts to the pager duty or email or HCD. So we can notify by using so email or a pager duty. In the real time, everyone are using the pager duty only. Okay. So short-lived objects, so parts are short-lived object. Push metrics and existing and jobs are exports. Prometheus is targets. So pull the metrics to retrieve the HTTP server. Through the HTTP server, we can push to the alert manager. Alert manager we can push to the pager duty or email. So once we get the pager, then we will check with what the service is having problem. So PromoQL. So Prometheus Web UI, you can use the Web UI to visualize the application. Yeah. So this is the GUI. We can visualize the application. SDA, SDB. These are the volumes. Volumes are how much volumes are is there, and the the memory and logouts. So these are the memory and logouts. These are the memory and CPU of the Kubernetes cluster. You see web server 1, web server 2, web server 3, web server 4, the differences, the CPU and memory. So this is the visualization of the Grafana. Guys, understood? This is so the Prometheus and Grafana and monitoring tools, right, guys? Yeah, I created the pages. I created the pages, but why it is not showing? Yeah, daemon set, right? So we were not discussed about the daemon set. A daemon set ensures that all the nodes run a copy of the pod. A node are added to the cluster, pods are added to them. As nodes are removed from the cluster, those pods are garbage collected. So deleting a daemon set will clean up the pods is created. So pods is created. So for example, ELK architecture. So I want to run the application logs on the all the all the all the pods, right? So Kubernetes provides a UI to Elastic Clutch, Elastic Kibana, and a Logstars, Elasticsearch. Logstars will collect the logs, so transformation to JSON, a message, and fed into the Elastic cluster. So then the Logstars will read the logs. So this is in the Kibana, we can see the logs. So first microservices log will be log stash through the Elasticsearch. They will show it on the Kibana dashboard. This is the Elastic ELK architecture. A daemon set ensures that all the nodes run a copy of your pod as nodes are added to the cluster, pods are added to them. As nodes are removed from the cluster, the pods are garbage collected. So deleting a daemon set will clean up the pods it is created. Some typical uses of daemon sets are so running a cluster storage daemon on every node. So that the cluster storage, collecting the logs and node monitoring. So for these three examples, cluster storage daemon, logs collection daemon, and node monitoring tool, we can use the we can use the daemon set. So replicas are not applicable for the daemon set. Okay. So it's a K8 resources to create the pods. Daemon set will create a one pod in each worker node. When we add a node to the cluster, the pod will created. If we remove the node from the cluster, then pod will deleted. So when do you use the daemon set, log collector, and node monitoring? So we can use for the so when do you use the daemon? So the log collector and monitoring node. So monitoring purpose we are using. So for the ELK purpose, we are using the a daemon set. We are using the daemon set. So Grafana auto scaling. Yeah. So metrics, right? Based on the metrics, so we will increase the parts and we will decrease the parts. So auto scaling. It is the process of decreasing the infrastructure based on the demand. So what is auto scaling, guys? Auto scaling is achieved over the metrics. The metrics, it is the process of decreasing infrastructure based on the demand. Auto scaling can be done in two ways: horizontal scaling and vertical scaling. Horizontal scaling means increasing the number of instances or a system. So horizontal scale means increasing the number of instances. Vertical scaling means increasing the capacity of the system. Capacity of the system. So auto scaling we have a two types, guys. One is horizontal scaling and vertical scaling. Horizontal pod auto scaling, HPA and VPA. So what are those, guys? HPA and VPA. Horizontal pod auto scaling or vertical pod auto scaling. What is that, guys? Horizontal pod auto scaling, a vertical pod auto scaling. We don't use the a vertical pod auto scaling because of so we will not increase the capacity of the server. So we will increase the automatically. So we will increase the automatically. So auto scaling, right? How many types of auto scalings are there? We have two, HPA and VPA. HPA is nothing but a horizontal pod. HPA is nothing but a horizontal pod auto scaling, and horizontal horizontal pod auto scaling, horizontal pod auto scaling, horizontal pod auto scaling, and VPA means, guys, tell me what is VPA? Vertical pod auto scaling, horizontal pod auto scaling, and vertical pod auto scaling. So what is horizontal pod auto scaling? So for example, this is our worker worker node 1. So worker node 2. Yeah. So this is the worker node 1, worker node 2. So this worker node 1 and worker node is fill up with the, so there is no space, there is no RAM CPU. So there is no RAM CPU. So I want to scale up the instances. I want to scale up the I want to scale up the instances. How we can the instances are a node. So what is the auto scaling, horizontal auto scaling? So we can increase the another worker node and we will install the parts. Worker node 3. So this is the worker node 3, worker node 1, worker node 2, worker node 3. So we can, so it automatically scaling the horizontal. If the if the metric CPU RAM is decreasing, so it automatically delete the auto scaling, removes the one instance. And so if the load is average something like, so we will set the threshold, something like a CPU memory. So once the CPU memory is, once the CPU memory is decreasing, it automatically scale down the instances. It automatically scale up the instances. It automatically scale up and it automatically scale down the instances. Horizontal pod scaling, auto scaling is nothing but horizontal pod auto scaler, which will scale up down number of pods replicas of the deployment. A replica set or a replication control dynamically based on the observed metrics. So based on the observed metrics, horizontal pod auto scaling. So here, so something like the parts, right? If the parts, the memory is, the worker node RAM CPU is completed, it will automatically spin up the another instance and it will create the parts. So it will create the parts. HP horizontal. So horizontal pod auto scaling. Horizontal pod auto scaler, which will scale up, scale down number of pod replicas deployment. Replica set or a replication controller dynamically based on the observed metrics, CPU memory utilization. HPA will interact with the metric server to identify the CPU memory utilization or the mod. So node. So for production, we will use the horizontal scaling only. So will not use the vertical scaling. Guys, understood? So horizontal scaling versus vertical scaling. So vertical scaling is nothing but we can increase the CPU, we can increase the capacity of the server, but horizontal scaling we can increase the instances. So while horizontal scaling refers to adding additional nodes, vertical scaling describe adding a more power to your current missions, more power to your current mission. Guys, understood? The auto scaling, horizontal pod auto scaling, vertical pod auto scaling. So Rafi, did you install the EKS? Rafi, Rafi, you there? Rafi, you're on sleep, huh? Yeah, guys. So we'll show you the example, guys. We'll show you the example. So do you have a EKS cluster? EKS cluster setup is done, right, from your side? So you are on mute, huh? Yeah, we'll show you ingress also, guys. So that cluster creation, EKS cluster. And the ingress is used to map the external URLs to the Kubernetes cluster service. Pods are accessible within the cluster. To expose the pods outside the cluster, we are using the service concept. So cluster IP, node port, and the LBR. We know the everything, right, guys? So ingress example, I want to yeah, in the domain I want to ingress. We need to use the same service. Ingress is used to map the external URLs to the Kubernetes cluster service. Pods are accessible within the cluster. To expose the ports outside the cluster, we use using the node port cluster IT or LBR. Most of the people are using your LBR, guys. Load balancer. So we'll tell you guys. Today we'll get the touch with the EKS team and will reactivate my account and I will show you guys. So I have a config map and Adi. So config map and secrets and we'll show you the metrics Grafana, how to install the Helm charts, how to install the Helm chart, how to start the Helm charts. We'll show you guys. So I installed everything. I verified it. It's working fine, but my account is suspended due to the billing. So I raised a request to the support team, wife of my pricing. So once they will activate, I will show you guys. Okay. Uh, yeah, guys. The CI/CD concept. What we will gonna discuss about the GitLab. So get started with the GitLab CI/CD. So we'll discuss this one. GitLab. What is GitLab? What is the create a first project? How to create the first project? Create a blank project and the project name. So project name. So if you want to use the runner, guys, so GitLab runners are a Jenkins server. So you can use it will deduct from your account, which will refund back. So you can use the validation check and validate the user account. So validation is done. So then create a first pipeline, guys. Create a first pipeline. So pipelines compares the two things, jobs and stages. Job is nothing but a defined. So I will show you guys. No worries, no worries. Create first CI/CD pipeline. The YAML dot gitlab.ca dot YAML dot. So it is passed. So what are the jobs? So what is the running state? What are the states we will discuss? Okay. So we'll discuss and we'll show you guys. We'll show you in the later classes. So first I need to show it on the Grafana and the Prometheus and the auto scaling ELK. We'll show you by and the Helm charts and the config map and secrets. We'll show it to you guys. Okay, guys, understood? So I will activate my account. Then we'll show you everything, guys. Then we'll show you everything. The Helm charts and everything will show you. Yeah. Now you understood, right? Helm chart. Why you are using the Helm chart? It's a package manager. You want to install the package. You want to install the package on the on the Kubernetes cluster. We can use the Helm chart repository, and we will install the package by using the Helm. Guys, understood?
Yes, sir.
Yep. So thank you, guys. We'll continue from tomorrow. Mostly I will get the account reactivated today and will show you guys. Or else I will create another account and I will show you. No worries. Okay?
Okay, sir.
Yep, thank you. So we'll continue from tomorrow.